Hi all, in this video I'm going to give a brief overview of how you can use DKube for medical image predictions. For this example, we're going to be using a set of pediatric chest x-rays pre-labeled by a pediatrician as having or not having signs of pneumonia. The model we'll be using is a simple convolutional neural network, which will be trained to recognize signs of pneumonia in lung tissue. The model will also be performing various pre-processing functions, such as conversion to NumPy arrays and simple augmentation. Once you log into DKube, you'll need to make sure you're in the data scientist role if it doesn't show up for you by default. Once you're at the data scientist dashboard, you can quickly monitor the status of all recently used resources, as well as the overall usage of the platforms you're assigned to. As we work through the example, I'll show how to load the code and dataset into DKube using the Workspaces and Datasets modules, how to experiment with different configurations in the Notebooks module, and finally, how to create jobs and models within their respective sections to utilize the model. Workspaces contain the programs that are available within DKube to train models. It's incredibly easy to add a new workspace if your code exists in a GitHub repository. You simply click on the Add Workspace button, be sure that the GitHub option is selected, enter a name for the workspace, enter the link to your GitHub repository, enter any optional tags you may want, and click Add Workspace. Now if we take a look at the workspace we just generated, we can see more details about it, such as its status, URL, and size. Next, we'll need to load the actual images we'll be working with inside the Datasets module. In this example, I've preloaded data into the DKube storage repository, so I just need to link to the appropriate path name. We'll add a dataset, click on the DKube storage option, enter a name for the dataset, and a link to the appropriate path. Notebooks allow you to experiment with your model in pre-processing code before running it through the formal job model pipeline. To create a new notebook, first click the Add Notebook button on the right. We'll start by giving it a name. Then, we'll choose several options for the new notebook in the drop-down menus here. Only the Start options are required, and if you'd like to look at all the options, the Expand All button can be toggled over here. This section is where you choose your container options, which we'll keep at the default for now. Here's where you can assign GPUs, if you'd like faster training of your models within the notebook environment. And if you set up links to the DKube environment within your code, you can use the hyperparameter section to alter those values from here. If you'd like to use existing code within Workspace, you can choose to do so here. Finally, the dataset and model dropdowns allow you to link to those sections for use in your code. Because we haven't set up any models for transfer learning yet, we'll only select a dataset and leave the model section blank. Once everything looks good, go ahead and click the Submit button to spin up the workbook. Once the notebook is ready, the Jupyter symbol on the left here will be visible. If we click on it, a Jupyter notebook will open in a smaller window. Now, if this generates an error for you, it's likely that the notebook needs just a bit more time to start up. Our saved work within the workspace can be accessed within the program folder here, which will open up the Jupyter notebook exactly the same as it would locally. Once it's open, we can interact with it exactly the same as you normally would. This step can be useful for exploratory analyses and initial model construction. Within the notebook itself, we can explore class distributions, visualize example images of different classes in the training image, experiment with augmentation techniques, and even evaluate the training patterns and activations of different model structures. Once you've reached a point where you're comfortable with the model and pre-processing steps, it's time to create the Python script and use it to run a job. Our saved scripts within the linked GitHub repository can be found within the workspace itself. When creating your py file, be sure to link to the environment variables you want to use by including the getEnv function along with the appropriate name. You'll also want to be sure to save the model weights appropriately using a TensorFlow saver so that it can be used later for inferences. To run the model, we'll first need to release any GPU resources we need. Because this environment only uses one GPU, I'll need to abort my notebook that is currently utilizing it before running a training job. Once that's done, navigate to the Jobs section and create a new training job. Although similar to creating a new notebook, with a training job you need to assign a workspace and also enter a startup script so that DKube knows what to process. We'll enter our training name, choose a container, which we'll leave at the default for now, enter our startup script, choose the number of GPUs to use, then select our hyperparameter values. Now DKube also allows for DKube-based hyperparameter tuning, so if you'd like to use this feature, this is where you'll upload your configuration YAML file. This is the YAML file we'll be using, which has some basic learning rate and epoch options. Finally, we'll choose a workspace and a dataset. A model is only used if you'd like to use transfer learning. Now once all this looks good, we'll hit the submit button and then wait for the job to run. Now that the job is complete, we can open up the hyperparameter tuning results to get a better understanding of the different hyperparameters that were chosen and how they performed. We can also open up the training job itself to look at the completion status of each individual job. Each job can also be opened up to view its log. We should see our expected output here. Now this is also a good place to look for error messages if the job fails to run. Additionally, when the job is complete, a finalized model will be added to the model section for each DKube job that was completed. Each of these can be used for inferences in the future. DKube makes it easy to run GPU-based deep learning models either in the cloud or on-premises. By providing access to familiar tools such as Jupyter, data scientists and other machine learning experts can focus on the models and their results, rather than spending valuable time working through hardware issues. For more information on getting started, please reach out to a DKube representative or look through the extensive documentation available in the help section.